What is a linked list? A linked list is a data structure used to store a collection of items. Unlike arrays, where elements are stored in contiguous memory locations, linked lists use nodes to store data. Each node points to the next node, creating a chain-like structure. Structure of a node. A linked list is made up of nodes. Each node has two parts. 1. Data, the value stored in the node. 2. Next, a pointer or reference to the next node in the list. Types of linked lists. 1. Singly linked list. Each node points to the next node, and the last node points to none. 2. Doubly linked list. Each node points to both the next node and the previous node. 3. Circular linked list. The last node points back to the first node, forming a circle. For simplicity, we'll start with a singly linked list. Creating a singly linked list in Python. Let's create a simple linked list step by step. Step 1. Define a node. We create a node class to represent each element in the list. Python class node, def init self-data, self.data equals data. Shaft data part of the node, self.next equals none. Pointer to the next node, initially set to none. Step 2. Create a linked list class. We create a linked list class to manage the linked list operations. Python class linked list, def init self, self.head equals none. Head of the list, initially set to none. Step 3. Adding a node to the linked list. Let's add a method to insert nodes into the linked list. Python method to add a node to the end of the list. Def append self data, new node equals node data. Create a new node with the given data if self.head is none. If the list is empty, make this node the head self.head equals new node. Return traverse to the end of the list and add the new node. Current node equals self.head, while current node.next. Current node equals current node.next. Current node.next equals new node. Step 4. Displaying the linked list. We need a way to see the contents of the linked list. Python have method to display the list. Def display self, current node equals self.head, while current node, print current node.data, end equals dash. Current node equals current node.next, print none. Hash full code example. Here's the complete code for a simple linked list with the ability to add nodes and display the list. Python class node def init self-data, self.data equals data. Data part of the node, self.next equals none. Pointer to the next node, initially set to none. Class linked list, def init self, self.head equals none. Head of the list, initially set to none. Method to add a node to the end of the list. Def append self-data, new node equals node data. Create a new node with the given data if self.head is none. If the list is empty, make this node the head, self.head equals new node. Return. Traverse to the end of the list and add the new node. Current node equals self.head, while current node.next, current node equals current node.next. Current node.next equals new node. Method to display the list, def display self. Current node equals self.head, while current node, print current node.data, end equal 1. Current node equals current node.next, print none. Example usage. Now let's create a linked list and add some nodes to it. Python create a linked list. Linked list equals linked list. Add nodes to the linked list, linked list.append 5, linked list.append 10, linked list.append 15. Display the linked list.display. Output, 5 bytes 10, 15. None hash explanation. 5 is the first node, head of the list. 10 is the second node, and it points to the next node. 15 is the last node, and it points to none, indicating the end of the list. Summary. Node stores data and reference to the next node. Linked list manages the sequence of nodes. Append operation adds a new node to the end of the list. Display operation shows the contents of the list. This should give you a good start on understanding how linked lists work. Let me know if you would like to learn more or need more examples.